So for organic nitrogen compounds, okay, we are going to learn about amine. Okay, so when we look at amine, okay, amine will have this structure C, okay, and then they have NH2. Okay, then they have, okay, others. Okay, so this one, anything that has amine, okay, so maybe I can simplify by writing R and then NH2. This is considered to be amine. Okay, so amine, they have classes. Okay, there are three classes. We call it primary amine, secondary amine, and tertiary amine. Okay, so primary amine is the same, the normal one. Okay, you have the nitrogen, okay, being attached to one R group. Okay, so that is going to be a primary amine. Okay, but do remember, okay, you can have the R group coming and attached to this hydrogen, and then one of the hydrogen is gone. Okay, so you have something like this. Do remember, nitrogen has total of 3 bonds, unlike like carbon, they have total of 4 bonds. But do remember, okay, nitrogen, okay, so maybe I'll ask Jody, do you think nitrogen has lone pair of electron?
Yes.
Okay, so nitrogen is group 5, so they do have lone pair of electrons. Okay, this one is very important for later part. Yeah, so even for ammonia, okay, they have lone pair, so it's the same thing only. So they can actually form 3 bonds. Okay, so this is going to be, if you have 2 R groups, that is going to be a secondary amine. Okay, so this one they say NH. Why NH? Because they have N and H. Or, okay, if you have tertiary, so the N, okay, so this one is bonded to R, another R, okay, so there is going to be lone pair of electrons. So this one is going to be just N alone. So this is going to be what we call as tertiary amine. So if you look at this example, okay, so you will see here, so there is one N, okay, and then there is H. So this is going to be one R group, another R group. So therefore, okay, this is going to be a secondary amine. Okay, secondary amine. If you look at here, okay, this is example of tertiary amine. So tertiary amine has only nitrogen. So you see nitrogen. Okay, so this is going to be one R group, and this is another R group, another R group. So there are 3 R groups, and therefore they are going to be a tertiary amine. Do not get mistaken. Okay, R group is always CH3. Do not do that mistake. Okay, R group is not always CH3. It can be also C2H5. It can move on C3H7 and so on. Okay, so R group, okay, can be anything. Okay, so any carbon combination. Yeah, so this is going to be the examples, and let's look at the name. Okay, how do they name? I think by now you should know how to write this formula. Okay, so you see CH3 and then NHCH3. This is what we call as structural formula. Okay, structural formula. Or you can write it down as CH3. There are 2 groups. Okay, so they write down CH3 bracket 2, and then there is NH. So they write it down like this. Okay, this is also going to be structural formula. The name, okay, you see, how do we name? We call it as amine. Okay, so if let's say there is going to be 2 R groups, and those R groups are going to be methyl, so there is going to be 2 methyl groups. So therefore we call it a dimethyl amine. Okay, a dimethyl amine. So here, this is also amine. Okay, so how do we call this? This is going to be 1 methyl, 2 methyl, another methyl. So it's a trimethyl amine. So this is how we write down the name. Okay, so another example, I think primary amines. Okay, you can see primary amines. So this is going to be 1 R group. Okay, so it's attached to NH2. So this is going to be known as methyl amine. And if it is going to be the R group, do remember I told you the R group is not limited to methyl only. It can be also C2H5. So this is another example, C2H5. So this is going to be what we call as ethyl amine. And if let's say you proceed to have C3H7, okay, so this is going to be propyl amine. Okay, methyl, ethyl, propyl, butyl, and then pentyl, and so on. Yeah. So you need to know all this. Okay. But the important thing is, if let's say the nitrogen has one R group, okay, one R group, they are going to be classified as primary amine. If you have, okay, two R groups, they are going to be secondary amine. And if you have three R groups, they are going to be a tertiary amine. So we have learned how to identify the amine groups, and we have learned about how to name those amine groups as well. Okay. So any questions over here, Charlton, before I proceed?
No.
Okay, so let's actually move on. Yeah. So let's actually look at basicity. Yeah. One whenever we look at ammonia, okay, ammonia. Let's actually see. Jody, do you think ammonia is acid or basic?
Basic.
Basic. Why we say ammonia is base? Why ammonia is base? How do you identify something is acid or base? Acid is a proton
Acid proton donator.
donor. Okay, so base is a
Proton acceptor.
okay, so they can accept proton, or in this case, if something can accept proton, proton is H plus. Okay, in order to accept that proton, it means that ammonia must have, okay, lone pair. Okay, ammonia must have lone pair, so that, okay, this H plus can form a dative bond with the NH3. So it means we are looking into something that has lone pair. Okay, something that has lone pair. So they are not donating the lone pair. Okay, take note, they are not donating the lone pair, but something that has that lone pair. Okay, but when we write down, so ammonia, so this is H, H, and H. Okay, this electron, they will be given to H. So this one is going to be ammonium ion. So of course, this is going to be coordinate dative bonding. So what is coordinate dative bonding? Is a special type covalent bonding. Okay, it's a special type covalent bonding. They're still sharing. Okay, so they are not donating the electrons like ionic. Yeah, they are not like that. Okay, but the arrow is telling that the electrons are moving towards the H plus. Yeah, so in order for something to act as a base, okay, it must be readily available to share its lone pair. Okay, must be readily available to share its lone pair to form dative bonding. So if you look over here, ammonia is a base. Okay, so how about amines? Okay, amine is also going to be the same. You see the primary amine, if you have one R group, you have H, another H. They do have lone pair of electrons. So if they have lone pair of electrons, of course, they will be able to bond with H plus. Okay, so they can donate the electron. Okay, or you can say they can actually join with the proton. It's a proton acceptor. Okay, it's a proton acceptor. Okay, so H plus will come from somewhere. Okay, they can form a bond. So therefore, they can behave as base. Okay, so they behave as base. So example, you can see how it works. Okay, just now I gave this example just now, NH3 plus H plus. So it's going to be proton acceptor. Ammonia is proton acceptor to give you ammonium ions. If you have primary amine, it's the same thing, RNH2. If you have H plus, the H plus will come over here. They are going to form RNH3 plus. Okay, so this is also going to be base. So other examples, you see examples, these are the examples. If you have ammonia, reacting with HCl. Okay, ammonia reacting with HCl. So the H plus, okay, will actually come over here. So you will get ammonium chloride, ammonium ion with chloride ions. Okay, so it's going to form ammonium chloride. The same thing if you have methylamine. Okay, methylamine reacting with HCl. Can methylamine react with HCl? The answer is yes, because they are going to be base. So any kind of amine, okay, not only methylamine, okay, any amine over here. Can dimethylamine react with HCl? Can trimethylamine react with HCl? The answer is yes. All these amines, okay, if they give you structure itself, you should be able to write the equation with HCl. Like for example, if I ask you how to write this equation involving CH3 3N plus HCl. Can I write the equation? The answer, okay, you need to know how to write the equation. The answer will be N, okay, this is going to be CH3, 3, okay, then you have H, okay, so this is going to be plus, and then join with this Cl, then minus. So this is going to be the reaction. Similar to how do you write ammonium chloride. Okay, you can see ammonium chloride. Okay, please actually take note of this. Okay, I will move on. Now, so methylamine, okay, they are going to have NH3 plus and Cl minus. Okay, so even though they just put plus and minus over there, do remember they are, okay, plus and minus will be cancelled out. So they are still neutral. Okay, they are still neutral. Plus and minus will be cancelled out. They are still neutral, but in this case, they are positively charged. They are positively charged. Okay. So in this case, you just see, yeah, there is going to be plus and minus. Can we ignore that? Okay, the answer is no. Yeah, can we ignore the plus and minus? Should we ignore that? No, because it tells us that, okay, it is amine reacting with something. Okay, so that is very important. If I see this, okay, I know that this is formed from ammonia plus HCl. It's just an indication for us, okay, to identify there is a reaction with ammonia and HCl. If we just don't simply write like this, it's going to be very difficult. Okay, we might think that it's just NH4 plus and Cl. This one still can understand, but how about this kind of equation? Is going to be quite difficult to make sense of it. Okay, so that is the reason why, okay, they write down this positive and minus. Okay, now when it comes to strength of base, okay, they have different strength of base. Okay, so ammonia and amines have different strength of base. It depends on the availability of the lone pair of the electron on the nitrogen atom to be bonded to the hydrogen atom. So they say that in this case, if you look at this diagram, they say that ammonium, okay, ammonium is less, okay, less is, or you can say ethylamine. Okay, ethylamine is more is a better base. Okay, it's a better base compared to ammonia. So why is that? Okay, so we need to know. Like for example, phenylalanine, okay, is going to be a weak base. Why is that? Okay, so the reason, okay, it depends on the availability of the lone pair, okay, on the electron, the nitrogen atom. So if you look over here, so if I ask you, okay, the same question, why ethylamine is the strongest base? Okay, why is that? Okay, and then why ammonia is stronger base than phenylalanine? Okay, the answer lies over here. Okay, where if you look at ethylamine, okay, ethylamine is going to be bonded with C2H5, and then you have NH2. So we know that there is going to be lone pair of electron. And if we look at C2H5 or any R groups are electron donating group. So if they are electron donating, okay, they are going to give the electron towards the nitrogen. If the nitrogen receives the electron, It means that, okay, this electron, okay, will be more readily available for bonding. Why? Because electron and electron, they will repel. Okay, so this electron will be ready for bonding. Okay, it will be ready for bonding. So if this is ready for bonding, so if I have another H plus coming here, okay, the electron will just go there. It will actually be bonded. So it will become a better base. Okay, it's a better base. But what will happen, okay, what will happen if, let's say, I have phenyl, okay, phenylamine. Now, phenylamine, okay, is going to be something like this. They also have lone pair of electron. But we have learned that, okay, whenever anything that is actually attached to benzene, okay, the electrons, they will go inside, okay, they will go inside, okay, the benzene ring, okay, and then we can say the electrons, the p orbitals, okay, they will overlap with the pi system, or basically in simple terms, okay, the lone pair, okay, the lone pair is going to be delocalized, okay, or stabilized, or will go and enter the ring and will become delocalized in the ring. Yeah. So it means that, okay, when they go inside, okay, what happens, okay, it's going to actually create a much more stable compound. Okay, it's going to create a much more stable compound because the electron will become delocalized. Okay, what happens now is this electron will be less available for bonding because they already committed themselves into the ring. So they will become less committed, okay, for bonding. So therefore, if let's say suddenly if I have for example, H plus coming over there and trying to actually say, okay, I want the lone pair, okay, so this one will not be readily available for bonding. Okay, so a dative bond cannot be formed. So because of that, okay, because of that, phenylamine, okay, will become a poor base, okay, a poor base compared to ethylamine. So you see here, okay, they have mentioned about, okay, the p orbitals in phenylamine. So this is going to be the electrons are in the p orbital. They overlap with the pi system. Okay, they overlap the pi system. So it means that they are these electrons, they actually come and delocalize within the ring over here. They are going to be delocalized across all the 6 carbon in the ring. And it will make it less readily available to form coordinate bonding. Because it's less available, then it is a very weak base. Okay, that's the answer for this. Okay, so okay, you can refer to the notes. Okay, until now, any questions? Lawi, any question? Okay, I hope it's clear. Yeah. Okay, so you should be able to identify which one is a better base, which one is going to be a weaker base, and so on. Yeah, very important. Yeah. If you move on, okay, now naming the compound. Naming the compound is quite easy. Okay, so maybe Charlton, can you help to name this compound? 2, 3, 4, 5. There's 5 carbon. So if you have 5 carbon, what is that?
Pentyl.
Yeah.
Pentyl.
So it's pentylamine. If you look over here, 1, 2, 3. 3 is propyl. Okay, propyl. So this one is 2. So it's going to be dipropyl amine. To answer this kind of question, okay, this one is similar like this. Okay, NH4 plus and Cl minus. So we call it ammonium chloride. So here, okay, if I want to write down, okay, so here the answer is ethyl ammonium chloride. How do I know? Okay, So this one is ethyl group. Okay, ethyl group. And then, okay, depending on whether it's going to be whatever it is, like for example, there is N bonded with Cl. Okay, so it means you are going to still write it down as ammonium chloride. So it means in simple terms, okay, how do I, so the name of this, okay, is going to be ethyl, okay, ethyl ammonium chloride. So if I actually rephrase this, okay, if I actually put another one, like for example, C2H5, and then I have 2, okay, and then N CH2, and then NH, okay, 3 plus NH2, sorry, Cl minus. Okay, if you have this kind of situation, if I want to name, okay, this is going to be, so this one is going to be ethyl and then 2, so it's diethyl. Okay, so you don't need to worry so much about this. Okay, this is going to be still ammonium chloride. Okay, and if I actually change this into CH3 and then 3, okay, and then I end up having NH plus and Cl minus. Okay, so Gabriela, Nicole, how do we name this?
Trimethyl
Yeah,
ammonium chloride.
yes, correct. Trimethyl ammonium chloride. So basically we are referring to this, yeah. So if you are not sure how to name, okay, refer to this ammonium chloride. Ammonium chloride not necessarily must be NH4Cl, okay, so it can be anything, okay. So it depends what is being bonded, okay. So if you have this, then ammonium chloride, okay. So the rest you just follow. Now, predict whether, okay, diethyl amine is stronger or weaker base than ethyl amine. So which one is or if I rephrase this, okay, which one is a stronger base? Diethyl amine or ethyl amine? Nicole, Trisha? Ethyl is C2H5, okay, C2H5 NH2, or C2H5 and C2H5H. Which one is a stronger base? Nicole, Trisha, you want to try? Which one is a stronger base? You're muted, I think. We always refer to the lone pair of the electron, okay? So which one, okay, whether 1 or 2, which one is more available for bonding, the lone pair? Victoria, you want to try? Which one will be more available for bonding? C2H5 is an electron donating group. So if you have one electron donating group donated over here, or if you have two electron donating group over here, which one, okay, will actually make this electron, okay, the lone pair of electrons, to be more available for bonding? Victoria?
The first one is it?
No? Remember the concept that I mentioned just now is going to be this one is going to be more available for bonding. Why? Because if you donate electron, it's coming from two parts, okay, this and here. So it means there's more electrons that is going towards the nitrogen. So it means that this electron will be pushed more, okay, to be available for bonding. So maybe you can put it push 2 times, okay, you to be available to be bonding. But here it's only being pushed only once. Okay, so the bigger, okay, the even if I want to compare, like for example, if you have a bigger R group, okay, a bigger R group will actually give you more electrons. Okay, it is donating more electrons. Like for example, if I want to actually compare C2H5NH2, and then I want to compare with C3H7NH2, which one is a better base? A better base will be this one. Why? Because this is going to actually donate more, okay, towards the NH2, and this electron will be more readily available for bonding. Okay, so this one you need to take note as well. Yeah, the bigger R group, okay, they will donate more. Or if you have more R group, then the electrons will push the electrons to be more readily available. So that is very important. Yeah. Now, yeah, Nicole, Trisha can go to toilet. Yeah. Now, if you have, okay, in this case, which one is a stronger base? Okay, we already identified it's a diethyl. Okay, diethyl amine is a stronger base. Why? It has two ethyl groups. Okay, so it releases the electron, making that the lone pair will be more readily available. Okay, for bonding. Okay, compared to ethyl amine, which has only one electron donating group. Okay, so based on my explanation. Okay, so this one is the part. Okay, so please take note of this. Okay, how do we know if something is electron withdrawing or donating? Yeah, this one, Justin, you have to memorize. Remember, I'm very sure you can remember this part over here last time. Okay, we have learned under benzene as well. Do remember, okay, any alkyl groups, okay, they are electron donating group. Okay, any alkyl groups or any R groups, they are electron donating. And the rest, okay, so this one normally for benzene, okay, but in general situation, all R groups are electron donating. Okay, all R groups are electron donating, but be very careful. OH, yeah, I think we have learned about this. OH, when it comes to benzene, okay, when it comes to benzene, OH is a electron donating group. Okay, OH is an electron donating group. Why? Because the lone pair of electron, they will try to enter the ring and so on. You know about this. But if I have alcohol, O is not electron donating group. They are electron withdrawing group. Okay, the OH is electron withdrawing. It's slightly different. Even if you have Cl, RCl alone. Okay, if I have C double bond O, Cl. Okay, this one we have learned, acyl chloride. Cl is always going to be electron withdrawing group. Why? Because, okay, Cl is more electronegative. But when it comes to benzene, okay, if you have benzene and you have Cl, Cl is going to be slightly different. The electron from the Cl will enter the ring. So they are electron donating in benzene. So this one you need to be very careful. Okay, there are some exceptions. Okay, we have discussed about this. So do refer to this table. This table is very suitable for benzene compounds. Okay, but if you just want to know for general, okay, generally R groups, okay, R groups are going to be electron donating. And then halogens, any halogens, okay, halogens, they are electron withdrawing. Okay, you can use it as your, even oxygen is actually electron withdrawing. Okay, but you can use it as a some kind of a guide, okay, to identify whether which one is electron donating, which one is electron withdrawing. Okay, this is only for the normal one. Yeah, we call it aliphatic. Yeah, straight chains. Okay, but if you have benzene, it's going to be slightly different. Now let's move on. Okay, so since we have learned about amines, so how do we get amine? Okay, how do we form amine? This one we have learned based on our lesson, okay, in the previous lessons, we have learned about this, but now we are compiling them together, okay, and we are going to add some equations as well, okay. So this one is not something new, okay. We have learned in the past, okay, when you learn halogenate alkanes under nucleophilic substitution, okay, halogenate alkanes will react with hot ethanolic ammonia, okay, hot ethanolic ammonia, and it must be excess, okay, to give you, okay, amine. So it can actually give you amine. So this one is going to be why we must use excess. Now the excess ammonia reduce the chances of this bromoethane, okay, being attacked by ethyl amine. So basically we don't want any other products to be formed, okay, because the ethyl amine itself, okay, this ethyl amine itself is going to behave as a nucleophile. Because why? They have electrons. If they have electrons, of course, they will behave as a nucleophile. So to prevent this to attack the bromoethane, okay, because I only want the ammonia to attack bromoethane, I use a lot of ammonia. So now ammonia is competing with ethyl amine. Okay, so both ammonia and ethyl amine are nucleophile. So now if you have a lot of ammonia, so the competition is not fair, okay? Because of course the ammonia will react with the bromoethane, okay? Rather than ethyl amine. Do remember ethyl amine is a very good nucleophile also. Okay, what is nucleophile? Something that loves nucleus, something that has lone pair. Okay, and do remember ethyl amine, the ethyl is going to donate the electron over there. Okay, electron donating group. So this electron, the lone pair, is very available for bonding. They really want to actually bond with others. So it's a very good nucleophile. So if you just leave it like that, okay, this one will actually attack this molecule. So we don't want that to happen. So that's why we use the excess hot ethanolic ammonia. That's the first equation. How do we get ethyl amine? How do we get any kind of amine basically? Okay, by reacting with ammonia. Next, okay, is going to be if you are using halogenate alkanes, again, halogenate alkanes, yeah, the same chapter. If you are using halogenate alkanes, there is one reaction, okay, where we can actually add the number of carbon. Okay, that reaction is known as reaction with cyanide ion. Okay, the KCN in ethanol, and then we reflux them. Okay, so basically what we do, we normally use this reaction with KCN to increase the number of carbon. Okay, let's say for example, if you look at this example over here, if you have CH3Br and I want to get another one more carbon to enter. Okay, so what we do is by reacting this with CN, you can actually get ethane nitrile. So you already have another carbon over there. And this carbon, okay, this nitrile group CN, okay, they will actually undergo some reaction which is going to be known as reduction. Okay, the nitrile, okay, nitrile, the CN nitrile, they will undergo a reduction reaction. Okay, how do we reduce them? There are three ways. Okay, there are three ways to reduce them. So this one, okay, you can reduce them. Okay, Aneta can go to toilet. You can reduce them by, if you have CH3CN, okay, what we will do, we reduce them CH3, we will add two hydrogen here. Okay, so you have CH2, and then we have nitrogen. Nitrogen has total 3 bonding, so 1 bonding is already there, so another hydrogen, another hydrogen. So how many hydrogen that we are going to add over here? There are total 4 hydrogen being added. That's why it's going to be adding with 4 hydrogen, and they will give you this amine. So it means that I can change nitrile. Okay, I can change nitrile into amine by using reduction method. And how do we reduce? There are 3 ways to reduce this. Okay, so the reduction can be done, okay, using LiAlH4 in dry ether. Okay, this one also I think you have learned about this. Okay, please refer to your book. Okay, carboxylic acid, okay, can be reduced. How can carboxylic acid be reduced? So we have already learned about this. Okay, lithium. I'll just write down over here. Maybe you can read more. Okay, LiAlH4. Okay, in dry ether. Go and read about NaBH4. Yeah, sodium tetrahydroaluminate. Yeah, sodium tetrahydroaluminate. Let me check. Yeah. LiAlH4, lithium tetrahydroaluminate. Okay, NaBH4, sodium tetrahydroborate. Okay, NaBH4, correct. Sodium tetrahydroborate. Okay, so this one, please go and find out about this. You can actually go and find out under carbonic compounds. Okay, please actually go and read about this. These are also reducing agents. Yeah, so go and find out about what it can actually reduce. Yeah. So anyway, so coming back to here, okay, so CN, okay, so, nitriles, okay, nitriles can be actually reduced, okay, by three methods. You can actually reduce them, okay, using LiAlH4 in dry ether, or you can actually use hydrogen gas in nickel catalyst, or you can use sodium in ethanol. Okay, there are three ways to do this. So you need to remember all the three ways. I think one of the way is not mentioned in the textbook, but they actually asked in the question itself. Yeah. So that's why I added over here. Okay. So please actually take note of this. Now, they said also we can use LiAlH4 in dry ether to reduce amide to amine. So this is actually another one more reaction. You can also change amide. What is amide? Okay. Amide is C double bond O NH2. Okay, the difference is there is a double bond O. If you want to actually change amide to amine, so what happened is, yeah, generally the O will be replaced. Okay, they take out the O, and then the H will come here, the H will come here. So how many H? 2H. And then the H have to come over here, the H have to come over here, so that you release this in water form. So how many hydrogen that you require? So you require 4. So you are going to get amine. Okay, so this is going to be another reaction. Amide can be also reduced to become amine. So there are total three ways, okay, how we can change, okay, how we can get amine. Okay, reaction number one, hot ethanolic ammonia, okay, with bromoethane. Okay, so you get this amine. Okay, excess. Okay, then you can reduce, okay, the nitrile. So you need to change it into nitrile first. Okay, so halogenate alkane, okay, will react with KCN in ethanol under reflux. They change into nitrile. Then after that, you actually do the reduction. Reduction can happen in three ways. You can use LiAlH4 in dry ether, sodium, okay, sodium in ethanol, or you can actually use the hydrogen using nickel catalyst. Three ways. Okay. Any question up to here? Let's actually recall whether you can remember. Okay, 3 ways how to get amine. Way number 1, Gabriela, Nico.
Reduce LiAlH4 in dry ether.
Reduce what?
Reduce the halogenate alkanes.
Reduce the halogenate alkane? No, halogenate alkane cannot be reduced. So this one, the first one, I think there are 3 ways. So I don't care whether you jumble up this. I think the last one was actually changing the amide. Okay, changing the amide to amine. Okay, so you can actually have any amide, like for example, if I have C2H5, okay, then another C double bond O NH2, I can reduce them, okay, into amine. Okay, how I can reduce them? I will use the LiAlH4 in dry ether. Okay, this is a strong reducing agent, so I use this. Okay, and then what happens? The hydrogen, okay, the hydrogen, they will come here, they come here, they come here. Okay, so I will write down carbon, so C2H5. Okay, you will have hydrogen here, NH2 is an amine already. Okay, plus, okay, the oxygen that left, okay, they will join with another hydrogen, so they'll give you H2O. So total, how many hydrogen that you have used? You have used total 4. Okay, so I put 4. So this is the way how you change. Okay, one of the way. Okay, how do you change the amide, okay, to become amine? But if you look at the other ways, okay, like for example, equation number 1, how do I change, let's say, any halogenate alkane? So if I say CH3Br, if I want to change this into amine, what do I need to do? I need to actually react with ammonia, and this ammonia must be under ethanolic, and this ammonia must be excess. Okay, must be under ethanolic or excess. And what happened? You are going to get CH3, the NH2 will enter, and then the Br will come out, one of the H, so you have HBr. So this is going to be another way, okay, where you can actually get the amine. Okay, so I think this one they mentioned you need to heat them up. Yeah, so hot. Okay, so excess hot. So this one must be hot. So hot condition. The second part, okay, is the part that is actually a bit tricky. Okay, so I'll write down over here. The second part is where you are going to change. Okay, let's say for example, I have this CH3Br, and I want, okay, I want C2H5 NH2, for example. Okay, from here I want to get this. Okay, if I want to get this, the first thing that you notice over here is, oh, this is halogenate alkane, I only have 1 carbon. So here I have 2 carbon. Okay, how do I actually change 1 carbon to become 2 carbon? There is only one method in chemistry where you can increase the number of carbon. Okay, in any kind of a situation. Yeah, so if you want to actually increase the number of carbon, if you have halogenate alkane, so what you do, you react this halogenate alkane with KCN. Okay, you react with KCN, and what are the conditions? You can see the KCN, okay, must be in ethanol, and then you reflux. Okay, so here, okay, it must be with ethanol and reflux. So if you do that, okay, what happens? You are going to get CH3, and then you have CN, and then this K and Br, they will give you KBr. So this is what we call nitrile. Okay, so this one is going to be a nitrile. So to be exact, I think the naming also, naming is not important, but I think it's ethane nitrile. So here, let me see, ethane CH3CN is ethane nitrile. So we will name it as ethane nitrile. So this is ethane nitrile. So this ethane nitrile, okay, you want to actually change this into here. Okay, you need to do reduction. Now, this reduction, okay, if I write down the equation, CH3CN, okay, plus H over here. So if you reduce, okay, what happens is going to be you are going to add one hydrogen here, one hydrogen here. And then you are going to add another hydrogen here, another hydrogen here. So total 4 hydrogen. So it will give you CH3, CH2, and H2. Okay. Okay, this is what we are going to get. So this one is the same as this, C2H5 and H2. So this, okay, the reduction can happen under 3 conditions. Okay, you can choose what reduction that you want. Okay, you can use LiAlH4 in dry ether. That is quite common. It's quite a strong reducing agent. Or you can use, okay, sodium in ethanol. Okay, you can use sodium in ethanol, or you can use hydrogen using nickel catalyst. Okay, these are the 3 ways. How do you change? But do remember from where we start. We start from here. In order to get this, how do you analyze? You need to actually change, okay, increase the number of carbon. It must be halogenoalkane reacting with CN. Okay, so sometimes, okay, they will ask you questions like this. Okay, they will ask you how from CH4, okay, how from CH4, if I want to get, okay, if I want to get C2H5NH2. Okay, tell me, how do we actually change CH4 methane to become C2H5NH2? Lavi, any idea? In order to get amine, what you need to do, you need to actually do 3 steps. It's either okay, you have halogenoalkane, okay, reacting with NH3, or if you have amide, then you have reduce or something like this. But if you want to have CH4 to become like that, okay, in this case, what I notice will be, I will notice one very important situation, 1C and there's 2C. If I have that, okay, the first thing is you need to react with KCN, but KCN do not react with CH4. KCN will only react with halogenoalkane. So you need to change this into halogenoalkane. How do you change CH4 into halogenoalkane? Lavi.
Is it reacting it with LiAlH?
No, I think you just straight away react CH4 with Br2 under UV light, and then they will give you CH3Cl and HBr. You already forgot this?
Didn't thought of it.
Yeah. So this is very important because now they are going to actually assess you on this. Okay, so you need to know. So first, you need to actually change them into halogenoalkane first. Okay, change them into halogenoalkane. Now I have halogenoalkane, and there is a way to change them into amine because halogenoalkane can be changed into amine. So How do I change into amine? If I have 2 carbons, so first thing that you need to do is to react this CH3Br that you get with KCN. So this KCN, okay, just follow what we have learned earlier. So this KCN must be ethanolic, okay, ethanolic, and it must be reflux, okay, ethanol and then reflux. So you do that reaction. So you are going to get CH3CN plus KBr. After you get that, okay, this CH3CN, you do the reduction. Okay, when you do this reduction, you are going to get CH3, CH2, NH2. So you need 4, okay, and you will get what you want. So this happens under what condition? You can actually use any of these 3, which is LiAlH4 in dry ether, or you can also use, okay, sodium in ethanol, or you can use hydrogen, okay, in catalyst of nickel catalyst. Is that clear, guys? Okay, this is one example of questions that they'll ask you, because they will actually try to combine everything. So
Sir,
now, yeah,
sir.
yeah,
Where did the H come from? The H.
this H is actually going to
Yeah.
be reduction. Whenever there is a reduction, like something like this, when something is going to be oxidized in your syllabus, when they say reduction, just put H. Okay, remember addition of H, that's going to be reduction. If you put bracket O, that's going to be addition of oxygen. So it's oxidation. So where it come from? It came from, this H came from here, it came from here, it came from here. These are reducing agents. Okay, but you do not need to write the full equation, just the H is enough. Yeah, so they are reducing agent. It's like something like a potassium manganate. Yeah, anything that you oxidize something, you just put like this is good enough already. Okay, something that is oxidizing something. Yeah, so it's just put like this is enough. So in this case, you just put like that. It's quite enough already. So please be careful. Okay, I will actually show you some questions later part. Okay, that's why I think I told you, please get ready. Okay, with all the organic parts, okay, so that we can actually start with our questions, because questions are involving all the reactions. Okay, so do go and revise your AS, starting from where? Revise starting from your alkane all the way to, I think the end of the AS is carbonyl compound. After that, okay, you do your A2 revision, okay, starting from benzene, okay, all the way to this chapter, which is going to be organic nitrogen compound. Because after this organic nitrogen compound, we will actually continue called chemical analysis and chemical synthesis also. So when we learn this, all these things will be assessed together. Okay, so you need to know all this knowledge. So the first thing, please go and read through all this. This is very, very important. Paper 4, it can be a killer, okay, if you do not know all this. Okay, so sometimes students think paper 4 is way easier, okay, even paper 5 is way easier if their knowledge on here is there. Yeah, and sometimes people will say, oh, transition elements, that's too difficult. But if you have memorized everything and the question 25 marks comes from there, of course you will be happy. So it's something like that. So please prepare earlier. Okay, this is very important. Okay, so everything that requires memorizing and so on, please do it again and again and again and again. Okay, so that will really help. Okay, So this one, okay, I have recorded this session. Okay, you can actually check. Later I will upload this. Okay, you can actually check over in YouTube.